There is a thick envelope of air around us called atmosphere. Air contains oxygen, nitrogen, carbon dioxide, water vapor and some inert gases. Constituents of air. Let us study this pie diagram. It will give us a clear idea of the proportion of various constituents of air. 78% nitrogen, 21% oxygen and 1% other gases are present in the air. 1% of other gases consist of carbon dioxide, water vapor, inert gases and other constituents.
Now, let us study about the most important constituent of air, oxygen. It is found in air in the free state. It is also present in water in the dissolved state. The survival of living things depends upon water. Now coming to the preparation of oxygen in the laboratory. Take a mixture of potassium chlorate and manganese dioxide in the proportion 5:1 in a test tube. Set up the apparatus as shown. Heat the test tube to 300 degrees Celsius. We can observe that the gas bubbles rise into the water-filled gas jar inverted over the water. Fill 3 to 4 jars with the gas. But how will you know that the gas jar is full? Oxygen takes the place of water in the gas jar. As oxygen fills more and more of the space in the gas jar, the level of water in it keeps falling. Oxygen is slightly heavier than air. Hence, it is collected by the downward displacement of water as shown. The following reaction takes place. When potassium chlorate is heated up to 300 degrees Celsius, potassium chloride is produced and oxygen gas is released. In this reaction, manganese dioxide acts as a catalyst, that is, it doesn't actually take part in this reaction. The following are the physical properties of oxygen. 1. Oxygen is a colorless, odorless, tasteless gas. 2. It dissolves sparingly, that is, not to a greater extent in water. Let us check out chemical properties of oxygen. 1. Take a gas jar full of oxygen. 2. Lower a lighted candle in it on a deflagrating spoon as shown in the figure. 3. Observe. We can observe that oxygen burns with a brighter flame. Thus, we can conclude that oxygen combines readily with other elements to produce their oxides. 1. When the wood in fire is burning low, blow on it with a blower. Observe. We can observe that the fire flares up and begins to burn vigorously. After some time, the burning slows down again. Thus, we can conclude that oxygen does not itself burn, but supports burning. Now let us move on to the uses of oxygen. 1. Living things need oxygen for respiration. 2. If a person cannot breathe, then oxygen is supplied artificially. 3. Mountaineers and divers are supplied with oxygen from cylinders. 4. For welding purpose, flames of the mixture oxyhydrogen at temperature 2800 degrees centigrade and oxyacetylene at temperature 3300 degrees centigrade are used. Just to check your memory, at the beginning of the chapter, we discussed the proportions of various constituents of air. Amongst them, nitrogen, 78%, is the major gas. So, now we shall learn about nitrogen in detail.
Nitrogen. Air contains nitrogen in maximum proportion, that is, 78%. It is an important constituent of proteins. Hence, it is important for the growth of living things, but nitrogen from the air cannot be used directly. So, nitrogen fixation is necessary before using it. Let us see what nitrogen fixation is.
Nitrogen fixation. The conversion of atmospheric nitrogen into compounds like ammonia and nitrates, which can be used by living things, is called nitrogen fixation. This is brought about by both biological and atmospheric factors.
Let us see biological fixation. Microorganisms that bring about nitrogen fixation are of two kinds. One of these types is found in the root nodules of certain leguminous plants, while the other types are found in the soil. The microorganisms in the nodules absorb the nitrogen from the air and convert it into nitrogen compounds. The microorganisms in the soil convert nitrogen in the air into ammonia, nitrous acid, and nitric acid, and eventually into nitrates.
Now, let us learn the second type of fixation, that is, atmospheric fixation. When there is lightning in the sky, atmospheric nitrogen and oxygen combine to form nitric oxide. This nitric oxide is oxidized again and nitrogen dioxide is formed. This nitrogen dioxide so formed dissolves in rainwater and finally forms nitric acid. This then falls to the earth. On the earth, it reacts with the salt in the soil to form nitrates. Plants use these nitrates for their own growth. Thus, nitrogen in the air becomes available to living things after biological and atmospheric fixation. So we saw that the nitrogen in the air gets converted into its compounds. But we know that the proportion of nitrogen in the atmosphere always remains constant, that is, 78%. How does this happen? The answer is through excretion and decay of living things, as well as through burning, nitrogen compounds get decomposed. Thus, nitrogen is released back into the atmosphere and the proportion remains constant. Uses of nitrogen. Now, let us move on to the uses of nitrogen. 1. Nitrogen is useful for the growth of living things. Plants get nitrogen from the soil in the form of nitrates and fertilizers. This helps them to grow. Also, plants use this nitrogen to produce proteinaceous substances. And as you all know, other living things use plants as food. Thus, this helps them grow too. 2. It is used for producing fertilizers. 3. It is used in industry for the large-scale production of ammonia and nitric acid. 4. It is used to make thermometers for measuring very high temperatures. Now we shall study about carbon dioxide. Though its proportion in the air is very less, that is 0.035%, its uses are real. Carbon dioxide is present in air. Plants use carbon dioxide from the air during photosynthesis and release oxygen in the air. This process takes place only in the presence of sunlight. About 100 years ago, the proportion of carbon dioxide in air was about 0.029%. At present, it has risen to 0.035%. There is danger of its rising even higher in future. This rising proportion of carbon dioxide increases the threat from greenhouse effect. But you may be wondering what greenhouse effect is, right? Greenhouse effect is the trapping of the sun's warmth in the lower atmosphere. This is caused by high levels of carbon dioxide and other gases. This further leads to increase in temperature of the Earth's atmosphere, that is, global warming. Students, you might have seen a gas gushing out of the bottle of an aerated drink when you open it. Did you think why it gushes out? The reason is carbon dioxide dissolves sparingly in water. Hence, it has to be dissolved in water under pressure. When the cap is prized open, pressure is released and carbon dioxide gas gushes out.
Have you ever heard of dry ice? If carbon dioxide is cooled to minus 57 degrees Celsius, it freezes. In this form, it is called dry ice. It is used to bring down the temperature of a substance suddenly. It is also used for preserving foodstuff.
Now let us move on to the study of water vapor. 1. Take a clean glass. 2. Dry its outer surface. 3. Place some pieces of ice in the glass. Observe. We can observe that little droplets of water get collected on the outer surface of the glass. Why does this happen? It is because the ice makes the air around it cool. Thus, the air turns into liquid, that is, it condenses and collects on the glass in the form of fine droplets of water. Some deliquescent substances, that is, substances which melt away, absorb water vapor from the air. For example, ice cream. This too tells of the presence of water vapor in the air. Clouds and fog are formed by the condensation of water vapor.
Inert gases. Chemically inactive gases, that is, inert gases like argon, helium and neon are present in the air in traces, that is, very small amounts. But they have many uses. Uses of inert gases. 1. Argon is used in electric bulbs. 2. Helium is used to obtain very low temperature. 3. Neon is used in the neon lights on hoardings that display advertisements. Now, let us discuss air pollution, a threat to our life. Air pollution. The progress in science and technology has given rise to industrialization, which is now taking place at a very rapid pace. The numbers of factories are increasing day by day. The factories discharge waste chemicals into the atmosphere, water and soil. They are in solid, liquid or gaseous state. When such chemical substances are collected in any place beyond a certain level, their harmful effects can be seen. This is called pollution. Causes of atmospheric or air pollution. Pollution is being caused by effluents, that is, the industrial waste discharged into river, seas, etc. These include contaminated water, dust, soot, chemicals, especially gas released in the atmosphere by the burning of carbon and sulfur. Lead, aluminium, zinc, acids, bases, etc. also cause pollution.
Effects of atmospheric pollution. Atmospheric pollution leads to a higher incidence of 1. Respiratory disorders. 2. Cancer of the intestines. 3. Disorders of the urinary bladder. 4. High blood pressure. 5. Night blindness. 6. Palpitation. 7. Breathlessness. And 8. Psychological disorders. Pollution affects not only animals but also plants. The lifespan of animals has decreased. Even their capacity of producing milk is seen decreasing. You know that plants carry out photosynthesis and produce energy. But air pollution has led to a fall in the photosynthetic production by plants also. Untimely falling of leaves, absence of fruiting, etc. are the other effects. The government and the public have taken up the task of controlling atmospheric pollution. Some of the steps to control atmospheric pollution are as follows. 1. Laws making it mandatory to treat chemical waste before letting it out of a factory have been enacted. 2. Efforts are made to bring about changes in the chemical process themselves so as to avoid the generation of harmful chemical substances. 3. Precautions should be taken to prevent the concentration of chemicals in any one place. 4. To prevent the harm caused by air pollution, industrial estates should be established away from cities and the height of the chimneys should also be increased. 5. Engines of motor vehicles should be serviced and maintained properly. 6. Forests should be grown. Do you know, friends, pollution causes acid rain? Let us learn about it in detail. Acid rain. Acid rain is one of the harmful effects of air pollution. Factories in big cities emit nitrogen dioxide and sulfur dioxide gases. As it rains, these gases dissolve in it, forming nitrous acid and sulfurous acid. These acids fall to the ground with the rainwater. That is why it is called acid rain. Acid rain can sometimes cause trees to die and fall. It also causes yellow patches on marble. Example: Taj Mahal, made up of white marble, is affected by acid rain.